Good morning, everybody, and welcome to the AWS Lunch and Learn series. My name is Mark Teistel. I'm a solutions architect in the partner organization, and today I'm going to be talking to you about best practices for running e-commerce sites on the AWS platform. So the first thing we're going to do is we're going to take a few moments and look at the topics that we're going to cover off today. So we're going to look at security, compliance, and scaling. We're going to talk about how do we scale our platforms, how do we architect e-commerce solutions appropriately through the decoupling of services to assist in meeting the demand that your successful e-commerce platforms are going to generate. We're going to talk about some of the tools, services, products, and platforms around product discovery and recommendation engines. And we'll take a truly global look at the Amazon Web Services platforms and how they relate specifically to delivering e-commerce solutions. On the call with me today taking your questions is Alastair Cousins. Alastair is a cloud specialist in our organization. So if you do have questions throughout today's presentation, feel free to use the questions capability in GoToMeeting, and Alastair will do his best to address those questions. So within Amazon, e-commerce is within our DNA. We started, as you know, as an online bookseller, and we're going to look at the evolution of the Amazon story as an underwriting narrative for the e-commerce platforms and the technologies that we've ultimately ended up delivering today as part of our platform. So AWS, being an Amazon company, has actually emerged out of an organization where e-commerce is the foundation of that organization. It is quite literally our birthplace. So if you look at Amazon.com and the journey that Amazon has taken, and ultimately the release of the AWS platform over the last 20 years, we can see a significant evolution through innovation, through scale, through speed, and through agility that has allowed Amazon to take technology platforms, whether that be for the delivery of packages, parcels, books, etc., and leverage the learnings taken from delivering that capability at a global scale and leveraging the technology platforms that facilitated that growth and led it as the AWS platform. So as I mentioned before, with e-commerce in our DNA, it's quite clear to see that the history has really informed the past and enabled us to produce a platform on AWS that is specifically suited for the release of e-commerce solutions. So if we look at where Amazon has come from, and where AWS is going as an underlying technology platform, Amazon has grown from the largest e-tailer to now the largest US retailer. And what's facilitated this growth is innovation at scale, agility, and speed. So these are some of the key tenets that we're going to touch on today as we talk about leveraging the AWS platform as an e-commerce engine for your businesses. One of the key things that we have taken away as Amazon from our business is the users generally will have a different requirement based upon the devices that they are currently using in order to interact with an e-commerce platform. So if we look at some statistics, 65% of users may start their interaction with an e-commerce online provider on a smartphone device, 25% on a PC or laptop, and the remaining sort of 11% on a tablet. But what's interesting about the multi-path device is, whilst they may start on one device, they may actually complete their transaction on a completely separate device. So the challenge here, as user behaviors continue to evolve, is to have organizations and technology platforms where agility enables the consistent delivery of a user experience irrespective of the device which they're using to access the e-commerce platform. So when we look at what solutions are out there in the market, there are a myriad of solutions. Many of these are available on the AWS marketplace. Many of these are available as commercial products, and a number of these can also be delivered by a number of our competent e-commerce partners. So of course we cover the ability to deploy all sorts of platforms, whether that be Magento, WebSphere, ZenCart, any number of the open source platforms, as well as integrations with third-party services for payments, for example. So what does this mean from a technology perspective? We've mentioned that there's a long history in terms of delivering e-commerce solutions from the Amazon perspective. There's a number of open source, commercial, and marketplace-driven solutions that can be implemented on top of the AWS platform. So one of the things I'd like to cover off in a moment is looking at least 3 of the well-established AWS reference architectural patterns. Now, all of these patterns are available in our architecture online information, so aws.amazon.com/architecture. So you'll be able to download these and have a really good look at what are the features and functionalities that AWS can support in order for you to bring your e-commerce platform to market. So each one of these architectures, in terms of the first one, part 1, talks about the web front end of an e-commerce platform. Part 2 talks about how to integrate with payment services, whether that be an Amazon payment service or another third-party payment service. And then part 3 talks about how do we take all that latent information that is sitting within the data that you're collecting on every transaction, on every web interaction, and making that available to your marketing teams, providing recommendations through recommendation engines, looking at things like sentiment analysis to understand how your products are being perceived in the market as you're bringing them closer and closer to the consumer. And what we'll do as we go forward in this presentation is we'll touch on a number of these technologies that are present in each one of these architectures. But if you are interested, I do encourage you to go and download these architectures and have a really good read of them. These are a great starting point in terms of really getting your head around the technology suites that are available to you in this space. But for many customers, the AWS journey may seem initially to be a daunting one. So we do recommend taking a simple approach from day one. So this is where we talk about just starting with a simple EC2 instance. EC2 is our Elastic Cloud Compute platform, which is the concept of virtualized servers. And you can start as simple as firing up an EC2 instance, installing your software, whether that's in-house or third-party software, and baking what we call an AMI. An AMI is an Amazon Machine Image, and this is effectively a store that allows you to encapsulate a configuration, an operating system, and to make that repeatable. So you can effectively start in a very comfortable, very simple environment just to find your feet in the Amazon environment. This is a great place to start. It's very simple. There's a number of guides online. And again, I'd highly recommend you, if you're new to the AWS environment, to start here on your journey. If we look back in history, as we tend to like to do, even Amazon had a humble beginning. So if we look at where the Amazon.com bookstore actually started, it was a simple EC2 single instance server running an AMI. And as you can see here, it's come a long way from there. And we would love to be involved in helping you take the same journey that we've taken with Amazon in terms of bringing to market an exceptional e-commerce offering. We can then go one step further in these architectures once we're comfortable with them and look at things like how do we bring robust and global domain name services into play here. And this is where our Amazon Route 53 service comes into play that enables you to have stable, scalable, and highly integrated DNS services sitting at the front of your e-commerce platform. If we look back into the stack a little bit towards the web server, our Elastic IP service sitting on top of a Amazon EC2 instance allows you to have nice, consistent IP failover. There's tight integration between Route 53 and our EC2 platform in terms of the Elastic IP. This means that if you have to destroy or reconfigure your EC2 instance, the Elastic IP and Route 53 will work together to ensure that that service is still available when that web server comes back up. We also offer an Amazon RDS service, which is our relational database service. This is a fully managed database tier that can be used across 5 database services, whether that be MySQL, MySQL, Oracle, Aurora, or MariaDB. This is a fully managed service that enables you to spin up your database tier very quickly, very simply, and in a fully managed fashion, where a number of the what we call the undifferentiated heavy lifting in terms of managing a database tier is taken care of by our managed database service. So we've looked at a very, very simple one instance example. We've looked at a 2-tier example, but of course, we hope that you'll be successful in your e-commerce rollout, and that's going to imply further scalability requirements as the demands of your customers and the market increase. So what we can look at here is how do we scale out in terms of an N-tier architecture. So we still include the Route 53 service to handle global DNS, but we introduce a concept here of an elastic load balancer. And the purpose of an elastic load balancer is to provide an entry point of traffic whereby that traffic can be distributed to back-end EC2 instances in a number of configurable ways. In this example, you may want to distribute traffic equally across the 3 EC2 instances that you can see in availability zone A. The database server based on the Amazon RDS service, as I mentioned before, it's a fully managed service, and one of the checkboxes that we enable is the ability to have synchronous replication across availability zones in a fully managed fashion. So in order to have a warm standby database with synchronous commit capability, the only thing that's required from a user perspective is to select that option when instantiating their RDS instance. So you can see here we've really very quickly and very easily gone from a very simple one instance environment up to now an N-tier reference architecture that enables quite some significant scale as well as high availability on the database in terms of warm standby capability. But again, there are other options that we have here in terms of handling scalability. So in the previous example, we had EC2 instances only sitting in one availability. We have these across availability zones to increase our high availability. In this example, we can make use of our auto-scaling capability. This auto-scaling capability enables users to look at utilization and consumption on EC2 instances and to fire up additional instances, get added to the pool of compute power to service your customers as that requirement is needed. When that requirement drops below a certain point, which is completely configurable, those instances will be terminated and removed from your auto-scaling group. So this is giving you what we call the horizontal scalability. We're also introducing in this high availability reference architecture the concept of the shared media assets based on the Amazon S3 service. So the S3 service is a large-scale object store service. And in this architecture, we highly recommend moving things like all static media assets, images, audio, video, etc. into S3. This offloads the requirement of the front-end servers to deliver this content and removes the requirement to scale disk capacity as static asset requirements grow. The S3 platform can handle significant amounts of these objects and can serve these directly. With the integration with Route 53, this can be a completely seamless experience from the user perspective. So we've introduced some great technologies to you, some great reference architectures, but how do you actually get started? As I mentioned before, we've got a number of partners that can assist you. You could definitely go in and have a try yourself, but we also have a number of marketplace offerings and AWS Quickstarts that can really get you going. So the AWS Marketplace is where a number of our partners offer these AMI images and services that can be purchased, paid for in various different commercial models. But these are pre-built services that can just be instantiated in the AWS environment, and this is an extremely rapid way of bringing your platform to market. We also have available a number of quick start reference deployments. These are very comprehensive documents, including templates and scripts. A significant amount of the required configuration is provided through GitHub repositories. And there's also public discussion forums where you can interact with other people who have implemented these quick start reference deployments in terms of helping you along. So there are at least two very, very rapid ways to get started, and we encourage you to have a look at both of these as options on your AWS journey. Along with our partners, they can also provide a managed service solution. So if you look at, for example, a Hybris solution, I believe I'm waiting for the slides to catch up. A Hybris solution, we have a number of partners that can support quite complex, quite large-scale, scalable Hybris rollouts, as well as platforms like Magento. And this is where you can basically offload the whole requirement for the build, deploy, and operate requirements for your e-commerce platform to a partner. Of course, those partners will be leveraging the power of the AWS platform underneath to deliver the capability that you require. But this is, again, another option that can help rapidly bring you to market. So in the Australian market, there are a number of partners that have gone through what we call our managed services program and have the marketing and commerce competencies, which basically is the audit requirement in order to pass certain minimum milestones and capabilities to be a certified provider of these AWS services on our partner network. So there are a number of providers here that are listed that we encourage you to reach out to if you'd like some assistance to bring your e-commerce platform to market. So if we take a step back for a moment and put the technology to one side, and we take a look at what are the typical customer expectations that are requirements from an e-commerce platform today. Well, first of all, availability is absolutely key. Your platform must be available all the time, 24 hours a day, 7 days a week. Your site needs to be highly performant and must be able to scale in real time to the demands of your customer base. Your content that you serve in terms of recommendations and products needs to be relevant to the user and their needs. And of course, as we say in AWS, security is everybody's day zero job. So your platform needs to be absolutely secure. So when we talk about availability and speed, it's no longer acceptable to have a platform that's gone out for lunch. Platform must be always available, irrespective of upgrades, maintenance, etc. The AWS platform has a number of architectural patterns that can facilitate this, and we encourage you to look at the high availability models or to work with your partners on having a look at those. And of course, speed is important. We know from research that 40% of shoppers will abandon a site that takes more than 3 seconds to load. So that's potential revenue that you're losing on a 3-second window. The AWS platform facilitates a number of different technologies to make sure that the delivery of your content and your services out to your customers is as quick as possible. We'll touch on a few of those later. Some of those include things like our CloudFront content distribution service. So what we'll do now is taking these tenets of availability, performance, relevance, and security, we'll have a look at what are the architectural and technology components within the AWS platform that can actually make sure that you deliver on these expectations to your customers. The first one we'll talk about is auto recovery on the Amazon EC2 service. So EC2 auto recovery is a service that enables a machine or an instance to restart when there's been an underlying issue. This means if a service is taken, if an EC2 is taken offline, for example, it will restart when it's available, when it is available to start again. Services such as RDS and ElastiCache, they all have options which enable high availability, and we've touched on the ability for synchronous replication. And some services, for example, our S3 service, are by default multi-availability zone and resilient by default. So it's important to understand here which services are being used within your architecture, what capabilities in terms of multi-availability zone and resiliency they have by default, and what options need to be configured to ensure you have the most available platform that can be delivered. Ultimately, a low RTO and RPO are expected for e-commerce platforms. So where it's possible, we always recommend to use all the high availability options where it's required against your customer requirements. We did touch earlier on the concept of auto-scaling. Here is another example of auto-scaling in the concept of availability and speed. So where there is significant load or where there is requirement for maintenance, auto-scaling groups can be used to ensure that there's sufficient resources available to handle the incremental load, and the elastic load balancer can be used to pivot traffic between availability zones to ensure your e-commerce platform is always up, even though you may be doing maintenance on one part of the platform in another availability zone. I mentioned before in relation to performance that we have a global content distribution service called CloudFront. So this service is a transparent service that can sit in front of your AWS services. It interacts with DNS, and the ability for CloudFront to understand the content that's being requested by your customers and determine which origin that content should be served from, and then distribute this content out to one or more of our 53 edge locations around the world. This has the ability to lower the load on your EC2 instances to provide better response times to your customers who are distributed across the world, and also to separate out the delivery of static content, which can be cached for quite some time, to that of semi-dynamic content or content that needs to be refreshed on a more regular basis. So the key message here is that content distribution is going to get your assets out closer to your customers through the CloudFront content distribution service and our edge caching capability. Within architectures, it's also important that our application servers are able to perform as quickly as they can. One of the elements of performance within e-commerce platforms is in-memory caching. Cache service comes in two varieties, even though they fall under the ElastiCache family. The first one is Redis, and the second one is Memcache. Memcache and Redis could be used behind or in front of your application instances to perform things like SQL query caching, database in-memory caching, as well as to provide the ability for microservices to query these caches as these microservices are coming up and down across your infrastructure. These caches can actually hold significant amount of cache content. On an R3 8XL instance, for example, which is one of our instance types, we can actually hold up to 1/4 terabyte in memory of cached content. So this will really offload a lot of the complex processing and data fetching requirements off to a highly scalable, significant sized caching engine, which will give your platform better performance. So what are customer expectations in terms of performance? Well, we've touched on these. So availability, scalability, speed, and performance being our key tenets, we can address these across the board in terms of performance. The first aspect that we can talk about in terms of managing performance is vertical scaling. So when we talk about vertical scaling, we're talking about resizing existing compute instances by making them larger in terms of their capability. This might be memory, throughput, or compute power. So this is really taking what you've got today and building upwards by adding additional capability. Another possibility is horizontal scaling. This is where we look at adding or removing compute resources and instances to match the changes in load as they happen. So just to recap Vertical scaling is around adding additional capacity to existing assets. Horizontal scaling is about adding or removing additional instances to an existing instance pool. Of course, in both cases, capacity planning and proactive scaling are going to be very important. It's very key to understand the service limits of your architectures and your platforms and your software that's being in use, and to proactively manage them. The AWS platform offers many capabilities such as auto-scaling, but it's still very, very important from a management perspective that you are continually monitoring and managing these compute assets. Now, why is this important? It's important because if we fail to manage capacity correctly, we'll get what we call the right sizing challenge, where as an operator of a platform, you'll continually be chasing the curve of demand. So you'll be able to see here that there are a couple of different models. A traditional model, say for example for an on-premise deployment, would be to deploy a significant amount of compute power, certainly enough to handle the highest peak loads, and then to let that run 24 hours a day, 7 days a week. The AWS platform allows you to elastically scale your compute power and to actually much more closely follow the curve of demand from customers. This means that capital requirements and cost are going to be significantly lower because you are not over-provisioning capability and compute power that's required to serve your customer base. So I'll continue on with explaining a little bit about this vertical versus horizontal scaling. So in the scale-up world, or the vertical scaling, as I mentioned before, this is where we add additional capability to existing assets. So you can see in the left-hand slide, the left-hand image, sorry, the scale-up model. This is taking an asset and just adding incremental compute memory or throughput power to that instance. Underneath that, you'll be able to see the auto-scale model. This is where the horizontal scaling comes into play. So this is where we add additional instances to an existing pool of assets, and we scale these out horizontally. The AWS platform is able to support both, and the decision of which way to go really depends on the software and architecture that you have chosen to deploy. The platform is capable of both, and the ability to manage both is handled quite well, both through the API, through the SDKs, and through our console user interface. When we talk about auto-scaling of databases, as I mentioned before, we have a number of databases that are available. There are two I'd like to touch on in the auto-scaling space. The first one is the Amazon DynamoDB, which is our managed NoSQL database service. So in this model here for DynamoDB, we have provisioned read and write operations per table. This provides predictable high performance, which is scaled through the console or the API. And an example here is it's fantastic for offloading things like session management. We always recommend deploying stateless applications where any state that gets stored should be stored in databases that can be recalled by any instance. It's important to remember that instances in an e-commerce model where we're either scaling up or we're scaling out, the vertical versus horizontal, that these instances are quite disposable and they will come and go over time to trace the demand of your customers. So it's important that as they come and go, they have access to state data, but they do not store state data. The second RDS service I'd like to talk about in terms of scalability is the Amazon Redshift petabyte scale data warehouse service. This is a fast, fully managed petabyte scale data warehouse. It's very simple to use, and it also has a significant amount of business intelligence tooling available, whether that's ones you'd like to bring yourself or ones that are available from third parties or through the AWS marketplace that enable you to do business intelligence and analytics across the Amazon Redshift service. So to recap on our auto-scaling concepts, we've touched on auto-scaling groups. EC2 instances, which are our Elastic Cloud Compute instances, are managed by auto-scaling groups. These groups can be created And within these groups, you can define minimum, maximum, and optionally the design be a response to a number of triggers that are configured within the auto-scaling group. Auto-scaling groups use launch configurations to actually fire up the EC2 instances, and they provide information about the AMI, which is the Amazon machine image, as I mentioned before, and the instance type that should be instantiated as a response. A scaling plan, which is attached to an auto-scaling group, as I mentioned before, tells us when and how to actually scale out this auto-scaling group. So there can be a number of conditions that can occur, and then dynamic scaling can be triggered to fire up or terminate instances depending on what these conditions are. So auto-scaling is really one of the most powerful tools that we have for aligning deployed infrastructure to demand. And this is where we talk about the right sizing and tracking that demand against the implemented assets that are out there in the platform. But these can't be used everywhere. So if we think about things like instance type and size choices for fixed workloads, you may want to have these initially very small and then scale these vertically for intense workload periods. Database sizing has some limited scaling possibilities without the downtime for adding what we call read replicas. In these cases, for databases, we should really be considering a blue-green strategy or a blue-green deployment for vertical scaling of the master, and this will give some scalability capability as well in terms of auto-scaling. And storage, we really need to understand in advance what the peak load looks like and what the peak storage requirements are, so when we are provisioning these elastic block storage services and attaching them to our EC2 instances, we have sufficient space on these. Now, service scaling is also an interesting attribute to discuss. So this is where we're using AWS services like DynamoDB, like Kinesis, for example, where sharding is going to be very important. It's very important that we understand the scaling ahead of time, so this can be proactively managed. So we'll move on now and we'll talk about customer expectation and content relevance. So as we all know, when we're offering our customers a choice of products and services, we want to try and make these as relevant as possible. And this is where things like recommendation engines come into play. Search engines as well, and the ability to collect, collate, analyze, and respond to user behaviors is very, very important. Relevance, I'd like to just touch on a number of services that can be used here to collect all of that data that your end users are generating as they browse, as they purchase, as they like, and as they recommend to other users across your platform. We don't want to lose this data because there's significant latent value that's stored within this data. What we want to try and do is collect this data and use it to improve the way in which we present data back to our users over time. And this is where we talk about periodic data and data streams and a number of AWS tools that help to collect, collate, and analyze this data. So periodic data is data that may come in consistently but over time. We build up this concept of a data lake, and we always recommend using our S3 service as a data lake because it enables us to store significant amount of data and to be able to consume this data into other services over time. Our Kinesis service enables us to ingest large streams of data continuously over time and to have these streams processed via our serverless compute platform called Lambda. Lambda can perform functionality like ETL, for example, and then push this data into the data lake. It can also trigger off capabilities such as machine learning, as well as writing records away, for example, to DynamoDB, which may be queried in real time for instant metrics across the platform. So once we have our data lake and this S3, we have three key services I'd like to talk about that enable us to increase our relevance to customers and understand customer behavior. So the first one is Elastic MapReduce, which enables us to run Hadoop jobs across the data in S3. Redshift, as I mentioned before, is our petabyte scale data warehouse. This enables us to store significant amounts of data and to query that data over time to understand user behaviors. All of this can be used to provide either instant or batch predictions around what the users may do in the future. So this is where machine learning and predictive analytics come into play. So this technology suite enables you to collect data, whether that be periodic or stream data, to effectively store it, cost-effectively manage it, and then use it as source data across a whole range of services in order to better understand your customers' behaviors. So we'll take a moment and we'll have a look at a data and insights sort of recommendations architecture. So if you look at this architecture here, you can see again we have the CloudFront service down for content distribution. We have our Elastic Load Balancer doing the internal distribution of customer connections out to web servers. What's interesting about this service is that log files that are being produced, as you can see, are being pushed into our Amazon S3 service. They're being held there so they can be queried by a number of different services, and this is just a representation of the previous slide. So the log file repository that's sitting in S3 can be used by our Elastic MapReduce service, pushed into a Hadoop cluster for processing, and then written back out to RDS in terms of a database of your choosing, and then that data can be fed back into S3, and an analyst can be used to do business intelligence and to gain business insights off that data, which is now stored in S3. So you can see here it's a very short extension from an N-tier web service model from an e-commerce platform perspective to enabling that platform to provide significant data analysis and insight capability. This is going to enable you to service customers better by really understanding what behaviors are being driven within the customers. So once we have this data, the key question is, how do we deploy the recommendation engine? How do we actually understand what this data means to us? And this is where our Elasticsearch, our managed Elasticsearch cluster comes into play. So a significant amount of that data that we've just spoken about before needs to be searched in real time. Our Elasticsearch cluster service includes services like Logstash, Elasticsearch, and Kibana, and enables a user or an API, for example, to query the Elasticsearch search engine and to use faceted searches, to use stemmed-based searches to produce search results that are relevant to the user. So when they're browsing and they're searching for specific types of things, the search results that come back are specifically relevant, and from an e-commerce perspective are increasing the chances of a successful sale of products to that user. And of course, analytics is one of the key components that we'd like to be able to use in terms of easily extracting value from this data that we're storing in the platforms. So as I mentioned before, some of the inputs to this are periodic data and streams data. So in terms of periodic data, there are a number of different sources that this may come from. It could be third-party exports in terms of shipping data, ad networks providing data back to you, database exports, purchasing histories, warehouse inventories, return data, credit card transaction data, for example. Streamed data or data streams may be click streams, carts updates and purchases, review information that's coming in real time, as well as market data that may be being collected from competitors. Once we have all this periodic data and stream data in a platform and in a model that can be fed through an analytics engine, we would like to get some output to actually understand exactly what's going on. So things like live metric dashboards are going to be very beneficial. User recommendations, as I mentioned before, to facilitate improved conversion rates, as well as search personalization. The ability to do targeted email campaigns, because we're collecting things like purchase history and competitor information, price matching, and constructive offerings may be built in real time, as well as stock level reconciliation and your general sort of business intelligence and reporting. So you can see here, by just taking a small step and utilizing a few additional services, significant value can be extracted from the data. The last point that I wanted to cover off on the customer expectation checklist is customer expectation of security. So there is no doubt that your customers expect your site to be secure. The key thing about security is that customer trust is hard to win and easily lost. A single security event might mean that customers will never come back to shop with you or to purchase your services or products again, and this can absolutely be catastrophic. At Amazon, we believe security is day zero for us, job zero, sorry, and this means that this first and foremost in our minds for everything we do. It's our number one priority, and we highly recommend that you make it AWS Cloud. We have a technical workbook that enables you to run through this workbook and effectively audit and manage your own security across your implementations. And again, we highly recommend that you have a look at this workbook and become familiar with it. Across the AWS platform, as we take security extremely seriously, we have a number of certifications ranging from PCI DSS through to IRAP and SOC 3. In our Gov Cloud, we have a number of government certifications as well as a number of industry certifications across our platform. So we absolutely highly recommend you to take security as your number one priority, as we do. What I'll do now is I'll take a few moments to have a look at the concepts of security by design. And there are 3 or 4 elements of security by design that I'd like to touch on. The first one is account fundamentals. So this is, how do you manage and maintain your infrastructure, ensuring that administrators, DevOps, security operations people have the appropriate access that they need in order to do their jobs, but no more, and that each operation and each login, each logout, each API call is being able to be tracked and be able to be audited in order for compliance. So it's quite common that multiple AWS accounts are split across appropriate boundaries. So some people may have access to pre-production and other people may have access only to production, but not to both. So it's quite possible within the AWS platform using our IAM capability to split out access within accounts and also access across accounts. And multi-factor authentication tokens for the root account and for any IAM account for users that are created as well. Now, we need to be able to monitor and to alarm based on our security stance and across our security policies. So we recommend enabling Cloud Trail and Cloud Watch. Both of these services will allow you to monitor and to alarm and to collect information around what exactly is going on within your accounts, and to be able to report on these for compliance. We also recommend the use of automation, and in this case, we are talking about the ability to replicate the environment required to ensure security of the accounts that are implemented within the environment. So automation here specifically relates to being able to replicate an entire environment within minutes, not just the infrastructure components, not just the service components, but also the user authentication components, roles, multi-factor authentication as well. The second element of security by design is infrastructure isolation. And this really talks about isolating components of the infrastructure into their specific functional components. So, for example, if you have parts of your infrastructure that require PCI DSS compliance, those compliance requirements are going to be quite different to parts of your infrastructure that may only be catalog, browse, and cart, for example. So it may be a requirement to separate out your infrastructure at a VPC level, or even potentially at an account level, to ensure complete separation of these responsibilities and to increase the overall security compliance of your platform. The third element I'd like to talk about is in our security by design part of the presentation is around the AWS Web Application Firewall. So the whole concept of using our CloudFront service, for example, is to expose the edge of your platform, but not necessarily the origin of the content. So our WAF, or Web Application Firewall, capability sits within our CloudFront product, and this enables you to centrally manage and protect the origin of your content from a whole range of typical vulnerabilities, from SQL injection to blocking specific IP ranges, matching on specific strings within requests, and allowing blocking or even counting specific operations that are coming near real-time visibility to what's going on in terms of content distribution. This is integrated, as I said before, with Amazon CloudFront and is a rule-based WAF engine. The final piece of secure by design is the VPC architecture. So VPC is our virtual private cloud. And as you can see from this diagram, there are a number of elements that we'll touch on as we walk through this VPC architecture. At the front of our VPC, we have a service called the Internet Gateway, and this is very much exactly what it stands for. The Internet Gateway, or IGW as it's labeled, enables your VPC to have access to the Internet. Behind an Internet Gateway, we quite often see a number of public subnets made available, so content can be served directly out of the VPC. Private subnets will generally sit behind this. They may or may not be in auto-scaling groups, but these private subnets allow a second tier of separation between the origin of content that may be being accessed by the public internet and other services that may sit behind that. For example, as I mentioned before, a caching layer or an Elasticsearch layer, for example. Security groups are used to protect these resources and make sure that only specific traffic that matches specific configuration rules is allowed to actually access those instances and resources across the VPC. Network access control lists apply across the VPC and provide a stateful, granular way of controlling access at the IP layer to the various resources across the VPC. The last element I'll touch on is the VGW, which is a virtual gateway or a VPC gateway, and this is basically a VPN termination point that provides a secure connection where administrators or third parties may be able to access the secure components of your architecture that may, for example, sit on private subnets that are locked away through either network access control lists or private subnets. So I've touched a bit on IAM, our identity and access management. What I'll do here is just go into a little bit more detail here to provide a bit more insight around some of the best practices and fundamentals that we need to understand to really lock down this component of the architecture. So the first tenet here is to implement the least permissive role-based access controls. So you need to understand exactly what specific roles need to do and only allow those roles to do those things and no more. Our CloudTrail service will enable you to maintain a full audit trail of change management as well as access management across the resources that you're consuming from AWS. You can federate IAM identities across accounts to use single sign-on and multi-factor authentication. This enables you to limit the amount of IAM configuration that you need to manage across these accounts, and to ensure that, for example, if you had 2 accounts, that IAM role 1 in account 1 is identical to IAM role 1 in account 2, for example, because effectively there would only be one IAM identity across both of those. Again, we want to create the least permissive IAM user and groups, and we want to aim here for some sort of role-based access control here, and preferably in some hierarchical model that makes sense for your application. IAM roles for applications are also very important. So we want to use IAM roles that articulate security stands for applications to access AWS services. This may be an EC2 instance having access to specific S3 bucket, or it may be a specific S3 bucket a specific S3 bucket being able to be written to or read from, for example, a Lambda function. And of course, we want to use appropriate permissions and split these across roles to provide what we call defense in depth. In order to facilitate this, encryption is also going to be a key part of your deployment. This is absolutely critical for customer and, of course, card data. At AWS, you always recommend encryption at rest and also encryption in transit. So we have a service called HSM, Cloud HSM, that enables us as clients of AWS to have control of your keys and crypto operations, but enables AWS to actually manage the hardware security module capability itself. KMS is a key management service that enables you to manage your keys across the AWS infrastructure. I do recommend you having a look at the AWS Key Management Service Cryptographic Detail white paper. That will go into a lot more detail for those of you who would like a lot more granular information on encryption using KMS and HSM. There are a number of services that we've recently announced as well. One of these services is Inspector. Inspector is a tool to assess and analyze end-to-end configuration and activities. This is effectively a configuration scanning engine and an activity monitoring tool. There's a built-in content library of CVE, network best practices, authentication best practices, etc. It's fully API driven and it's fully auditable, and Inspector will enable you to analyze all the traffic through continuous scanning of traffic and to understand exactly what's going on from a continual assurance perspective. The second product that we've announced recently is AWS Config and Config Rules. This is a tool to continuously monitor the configuration of new and existing resources and to evaluate these against specific checklists that you have either written yourself or consumed as templates from AWS. These rules are quite flexible and they're continuously evaluated continuously and retroactively, and the results of these of this continual assurance process is shown in a dashboard and is also reported. As a result of this continual assurance process, actions might be taken, things like emailing an ops team or triggering specific Lambda functions to take direct action. For example, if a significant amount of rules were violated, Lambda may actually, you may take to further lock down an EC2 instance, for example, or even to terminate an EC2 instance. And of course, as with the majority of the AWS services, this is also fully automatable via the API. So we'll take a different tack now and we'll quickly move on to really what does a business want here and what is business agility and how do these services and architectures enable business agility. So the ability of a business system to rapidly respond to change by adapting its initial state, its initial stable configuration. This is what we see as business agility. The key element here is to be able to rapidly respond to change. One of the ways that we see many of our customers implementing e-commerce services and being able to rapidly respond to change is to architect their applications in such a way that they are decoupled and have a very service-oriented architecture. So we see many legacy applications being re-architected and split out from being a monolithic application into multiple loosely coupled services. We see companies and customers operating services independently, and many organizations use circuit breakers, whether that be process or technological circuit breakers, to allow services to fail in isolation. So for example, in this model, the catalog service may be able to fail in isolation of the search and vice versa. So what does this mean? Well, what this means is we actually take quite a different architectural style. So traditionally, we've seen many monolithic applications that have relatively simple deployment methodologies, very binary failure models. It's either functional or it's failed. A lot of intermodule refactoring required when changes need to be made. Technology monoculture, so a very one-sided or very focused on a specific technology culture, and traditionally monolithic architectures will scale vertically. As we see the industry transition to microservices, we're seeing partial deployments. So the ability to deploy only part or even a fraction, a very small fraction of the overall system. Graceful degradation, where one part of the architecture can fail and not impact another. We see very strong module boundaries being built, which is driven by strong API and strong integration capability. We see a whole diverse range of technologies being used. And as a consequence, a more appropriate horizontal scaling approach is being taken. Now, monolithic architectures are basically organized based upon organizational and technology capabilities. So we generally see user interface teams, app logic teams, and database teams in terms of organizational structure. However, the application architecture may be web tier, app tier, and database. So these two map quite nicely, but as we want to increase our agility and we move to microservices-based architectures, we see organizations reorganizing themselves along business responsibility lines. So we see login, registration, and ordering as opposed to a UI component. We see personalization being driven by a personalization team where this may not even have existed before in a monolithic approach. And we see mobile being a critical element. So we have specific mobile teams and mobile technologies being used. And of course, as we move to microservices, we also see a significant evolution from monolithic architectures to microservices and containerization. So you can see in this model here, we have a whole range of microservices being used to offer services like user profile services, recommendation services, an offering engine, for example, and email services, for example. So this is just a sample of how moving from monolithic to microservices can be facilitated by a containerization approach. Of course, there's a significant amount of tool sets out there that can facilitate the acceleration of agility through continuous integration and delivery. We generally call this CI/CD, continuous integration and continuous delivery. AWS has a significant tool set, as do many of our partners. Our Code Deploy product, Elastic Beanstalk service, and CloudFormation all work together to facilitate the ability to rapidly deploy code, deploy changes in a timely, consistent, and robust fashion. The last key element I'm going to touch on is tying all these together in terms of cost optimization. We've covered quite a significant breadth of technologies and business approaches here. One of the key things everybody will always be focused on is, can we do this cost effectively? So the key drivers here are really 5. We want to make sure that we're right-sizing our instances to match our requirements. And this is where we can talk about the elasticity of cloud, horizontal scaling, and auto-scaling groups. We also have this concept of a reserved instance. A reserved instance is an always-on instance that allows you to have a reduced cost for a overtime commitment that you'll be making to AWS. I mentioned auto-scaling before. We also have a spot instance where you may have significant number of batch jobs that need to be processed. Spot instance is a marketplace for compute resource. And of course, if you're not using capability or services, turn them off, and that will also reduce your cost. So we're heading towards the end of our presentation. I thank you for your time. I do encourage you to reach out to your AWS account team if you'd like more information. I'm going to give some dates in a moment on some additional 201 deep dive sessions that we're going to have. And I do encourage you to have a look at the AWS Quickstarts. You'll all receive this slide deck at the end of the presentation, so I encourage you to have a look at the resources, and please feel free to reach out to your AWS contact. I'd like to thank you all for your time today. It's been a pleasure to present to you. I hope you enjoyed today's session and look forward to talking to you again soon. Thank you.